Hi there. What do you see in this image of a cloud? A bunny? A puppy? Spain? I see a whole aspect of climate change that's not well understood and an underestimated source of error in climate prediction. Let me tell you why. We've been hearing about climate change more than ever, and for good reason. The consequences of global warming are increasingly severe. I'm talking about a 1 million ton loss of ice per minute that leads to rising sea levels, sinking coasts, and an increase in extreme droughts, hurricanes, and fires. Things that affect over 6 million people a year. That's almost the entire population of New York City. If we don't slow the climate crisis, the consequences are due to become worse and permanent in just 30 years from now. Despite the urgency of the situation, we still don't understand the mechanism of climate change completely. It was previously believed that if we control and understand greenhouse gases, we'll solve global warming. Turns out that's just half the story. Our climate system also includes interactions between solar radiation and tiny particles suspended in the air that can form clouds. These clouds can reflect radiation in all directions, and that interaction is complex and yet to be fully understood. So, what are these particles, and how can they form clouds? Well, since the dawn of the industrial era, human activity have pumped an excess amount of particulate matter that becomes suspended in the air, commonly known as aerosols. They're made up of various things: organic, inorganic, and even biological matter. These particles are tiny. I'm talking about a fraction of the diameter of your hair and can stay lofted in the air for long periods of time. These suspended particles provide a surface for water vapor to condense onto and create droplets, the building blocks of clouds. Now here's the kicker. Unlike greenhouse gases, the presence of clouds tends to lead to a cooling effect on our atmosphere. The mechanism of this interaction is similar to your car's sunshade on a hot summer day. Instead of allowing sun and heat in, these particles reflect them back out to space. The main issue is that the magnitude of their effect on climate and weather are still uncertain. So enter my research. In the lab, I study how effectively different classes of aerosols form clouds. And the best part is, I get to recreate atmospheric conditions in a controlled setting and observe the changes in these particles. To get into a little detail, the instrument I use allows me to create aerosol particles, just like the ones we would find in ambient air, and expose them to varying temperatures and humidities. To see if they form cloud droplets, I shine a laser on them, and the detectors measure how much light gets reflected and refracted by the formed droplets. This information tells us how readily an aerosol particle forms a cloud droplet at a given atmospheric condition. In essence, in the lab, I recreate a slice of the sky at a moment in time, observe droplet formation, and interpret its climate implications. My measurements can be used to classify cloud forming and non cloud forming aerosol particles and help climate modelers form a more accurate prediction of the future of our planet. In the future, I hope to see my research reach the broader community by providing the facts that inform policymakers to create sound and environmentally friendly regulations. So, what do you see now?